Alright, so question 27 states, in triangle DEF, DE is 7 centimeters, which I've drawn over here, and EF is 12 centimeters, which we have over here. And it says, which of the following could be a possible length of DF? So this is one of those facts that we talked about that we said, we called it the triangle inequality theorem. And we said that if we add two sides of a triangle together, it always has to be greater than the third side. So let's do that. Let's take these two sides and add them together. If we add 7 plus 12 together, we get 19. So we know that these two sides have to add together and be greater than this third side. So this third side can't be 19 or anything bigger. Because if it's bigger than that, then we're going to break the rule. If we pick 22, then 7 plus 12 is not bigger than 22. If we pick 19, 7 plus 12 is not bigger than 19. And that quickly eliminates two of our answers. We see that C is 19. We know this side cannot be 19 because those two things up here, 7 and 12, do not add up to be bigger than 19. Likewise, 24. 7 and 12 do not add up to be 24, or more than 24. So we know that answer does not work. And that leaves us just with two options then. It's either 5 or 10, which is A and B respectively. So we can take both those things and try them. We're going to plug in 5 and we'll plug in 10 and see what happens. So if I plug in 5 as a possible answer here, and we look at this, well, now we've got something different. Earlier I was trying to add these together as the two small sides, but we can see even if I use 10 or 5, it's always going to be the 7 and that number are the smallest one. 12 is now the biggest side. Even if it doesn't look like that from the picture, we know it's true because we just eliminated the other two possible answers. So let's try plugging in 5 here. If I add 7 and 5 together, we get 12. Is 12, these two add together, greater than the third side? Well, no. We know 12 plus 12, 12 is not greater than 12. So this option can't work. We can't use 5 because then these two sides don't add up to be bigger than the third side, which leaves me with one option, 10. So let's try that. 7 plus 10, we know that's 17. Is 17 greater than 12? Yes. So it seems like the correct answer for here is 10, and we could check all three sides. 7 plus 10, 17, that's greater than 12. 12 and 10, that's 22, that's greater than 7. And 12 and 7, 19, that's greater than 10. So it looks like 10 is the correct choice, which is answer choice B. Alright, so let's take a look at this next problem. 27. We've got triangle DEF, and we have this side is equal to 11, and this side is equal to 13. And we don't quite know what's down here at DF. And the question says, what is the classification of the triangle? Is it acute, right, obtuse, or not enough information? Well, let's kind of go back and think about this again. Remember, we used this c squared blank a squared plus b squared method to solve this. And we knew there were three things that can go in here. If c squared is bigger than a squared plus b squared, we know it's obtuse. And a common mistake is that these two things here, this a squared plus b squared part, gets switched with c squared. So then we have a squared plus b squared on the left and c squared on the right, because it's kind of the more common way to do it. A squared plus b squared equals c squared. And then this sign gets backwards. You always want to make sure you focus on c. Is c squared bigger? Yes, it's obtuse. If it's smaller, well then it's acute. And if they are equal, it's a right triangle. So I'm going to pick which one I plug in for C, but we have a problem. I don't know what's down here. I have no idea what this side is. So I know this side's 11, this side's 13, and that's something I don't know. So what do I plug in for C? Not a clue. Have no idea. This problem actually comes out to be that answer D. We don't use that very often, but it's not enough information. They didn't tell me anything. What is that? I don't know what that is. Go away. Whatever. I can't draw an I down there. Net. Not enough information. D. So because we don't know that missing side, not enough information, and that is the end of that problem. Very simple. We don't have to do very much work there at all. Alright, on to 28. 28 gives me this figure ABCD, which is a kite. And it says find the measure of angle C. Pretty straightforward question. Go back to that last week before break, and we learned that there is a special relationship between one pair of angles in kites. A and C There's nothing important about them. Not a single thing. But D and B do have something very important that we need to know, and that's that this little line and this big line, and this little line and this big line, they come together and meet, and they make angles that are exactly the same. So if this part of the kite's 100, this part of the kite's 100, well, then we know, oh, sorry, if this part of the kite's 100, then we know this part of the kite's also 100. So A is equal to 93, B is equal to 100, and D is also equal to 100. Which leaves me with just that one missing angle, C. So this is actually just like those triangle in third triangle triangle problems we've been doing, where I give you two angles of a triangle and you find the third one by adding it all up, subtracting it from 180, because we know all triangles add up to 180. Remember, we said all quadrilaterals, quads angles, equal 360, exactly double that of a triangle, because it's technically two triangles. If I were to put a dotted line right here, it's a triangle on top, triangle on bottom. So we're going to add this all together. So if I add this up, we get 100 plus 100 is 200, plus 93 gives me 293, and then we just take 360, subtract that 293, and it looks like we'll get 767 degrees. And that is the answer to that problem. So it would be answer choice B. All right, so we're on to 29, which I didn't number on here. There we go. 29 says each of the following statements about these similar pentagons DEFGH and JKLMN is true except. So we're choosing the false statement. So I drew some very rough, crude versions of them here. You have them right in front of you, which makes it a little bit easier to see, but we're going to kind of just work with my picture so that I can explain what I'm trying to talk about. A says that the ratio of the corresponding sides of the pentagons is DEFGH and JKLMN is 2 to 1. So it's saying that this one is exactly 2 times bigger than this one. This side is twice as big as the corresponding side to the other one. That'd be really hard to figure out. The only way we could do that is we'd have to do the distance formula from here to here and distance formula here to here and compare if it's a 2 to 1 ratio. And that seems like a lot of work. So I'm actually going to just hold off on A. We'll come back to that if we need to. But we actually don't need to. If you look at B, immediately it's going to help us out. It says pentagon DEFGH, that's this big one, is twice as big as JKLMNN. Well, if it's twice as big, then it also has a 2 to 1 ratio. Meaning if I decide that 2 to 1 is false, well, that means that it can't be twice as big. So I'd have to eliminate both A and B. And it doesn't say eliminate 2 answers. It says eliminate 1 answer. If I decide pentagon DEFGH is not twice as big as JKLMN, well, then I'd have to eliminate the first one too, because that's the 2 to 1 ratio. If it's 2 to 1, then it's 2 times as big. So either A and B both have to be true, or A and B both have to be false. So we don't have to do any distance formula, because we know that we can't eliminate both of them, so they both must be true. Then says C, both pentagons have corresponding angles that are similar. So remember, we said similar figures. We talked about that, I think, like Thursday before break. We said similar figures must have congruent angles. And if you look in the directions of this one, it says these are two similar pentagons. So if the pentagons are similar, their angles have to be the same. So that leaves me one more choice, D. JKLMN is the direct result of a translation of DEFGH. Remember, a translation means that we just take a shape and we just move it down and to the left. It would say that this one went down and to the left and nothing changed. Well, this one was really big and this one's really small. Something definitely did change. So we could say that D must be true. It is D must be false. It is not the result of a translation. So this is the incorrect statement. The only statement that is not true is D. Alright, next up is number 30. Number 30 says, two trapezoids in the figure are similar. ABCD is similar to LMJK. If the lengths of the sides BC, CD, and JM are known, then what other side length can be determined using a proportion? So a proportion is stating that if we know two sides that are corresponding, like BC and JM, BC being on top and JM being on top, they correspond to each other. CD and JK correspond to each other because they're both starting at the top going down to that 90-degree angle. So if we know two sides, well, we can use that proportion to take one side of another one and change it into the third one, or into the second one. So in this case, it tells me BC and CD. We know BC, this one, and we know CD, this one. And it also states that we know JM. So we'll put 3 lines here. So if I know BC corresponds to JM, we know there's a correspondence there, BC corresponding to JM. Well, I can set that equal to a proportion of CD going on top as well. Notice BC came from the little triangle, or sorry, the little trapezoid, so CD also has to be on top because it comes from the little trapezoid. Well, then we're just deciding what side CD corresponds to. We just talked about that. I just said it. It's going to be J to K because it's starting at the top and going down to that 90, just like over here, top to the 90. So JK must be the piece that goes here, which is answer choice B. Alright, so on to 31. 31 says the two trapezoids in the figure are similar, with ABCD being similar to LMJK. Kind of similar to the problem we just did up top. And then it says if AB equals 10, so let's just fill this in as we go. AB equals 10. And it says that AD equals 12. CD equals 8. Finally, LK equals 18. I don't know what I'm doing there. 18, there we go. It wants us to find LM. So there's actually extraneous information here, stuff that they added that we don't actually need in order to solve this. We know that the 18 here corresponds to 12 because they're both the bottom. And then over here, this question mark that I'm looking for, well, that's this kind of slanted side that's across from the 90. Well, if we look over here, this 8 is next to the 90. It's useless. We don't want that. We want this 10 that's across from the 90. So then we can set up our proportion. 10 over 12 is equal to the question mark over 18, or we can put an X here. Probably a little bit easier, more mathematical to work with. So if we're trying to solve a proportion, if I have a fraction equals a fraction, well, that gives me the option of cross multiplying. So I'm going to cross here and cross here. So 12 times X gives me 12X. Bring down my equal sign. 18 times 10 gives me 180. And now we've just got a simple one-step equation. We'll divide this side by 12 and this side by 12. We cancel out here and get X equals, off the top of my head, let's see, 12 goes into 120 10 times, goes into 65 times, so we've got 15. So X equals 15, and that is what LM equals. So we can also put over here LM equals 15 because that's actually what we want to say, not X. We're not looking for X, we're looking for LM. And that would be answer choice B. Alright, on to 32. 32 says, Desiree is designing 2 flower beds in her backyard. The flower beds are to be similar rectangles. The length of the larger bed will be 8 feet. So let's draw her larger rectangle flower bed, and she wants the length to be 8 feet. And then she has a smaller flower bed, and she wants the length of that one to be 4 feet. It then says Desiree wants the width of her larger flower bed to be 5 feet. So the question's asking, what must be the width of the smaller bed in order for it to be similar? Well, we can see right here, there's a ratio. This length and this length have a ratio of 2 to 1. This one is exactly, the bigger one is exactly 2 times as big as the smaller one. So if this length is 5 feet and we want to fit something here that makes it exactly half the length, well, we're just going to take 5 and divide it by 2. And if we do that, we would get 2.5. So that means that the width must be 2.5, which is answer choice A. Alright, on to 33. 33 has this picture here that says an equilateral triangle is contained within an isosceles trapezoid shown above. What is the measurement of the largest angle within the diagram, ignoring the straight angle. So it's asking us to find the largest of all the angles in here. So there's a couple options that we could look at. So let's start here. This equilateral triangle. We know all equilateral triangles have the exact same angles. Because all sides are equal, all angles have to be equal. And the only way to get all three angles to be equal and still add up to 180 is to make all three of them 60, 60, and 60. So that leaves me this angle right here as a possible contender for the largest angle, or this angle up here. Let me switch colors, and that might help you see that. I think I can switch colors. Who knows what I can do on here. So this angle right here, or this angle here could be a possible contender. Well, we know if this angle here is 60, in order to make this straight angle be a straight angle, we know this one here has to be 120 degrees. So that's one possible option. And up here, if we know this angle is 60, well, remember we talked about this with a trapezoids. We know that this angle and this angle have to add up to 180. And this angle here and this angle here are exactly the same. So this angle's 60, we know this angle's 60, not the biggest. But if this one's 60, this one has to also add up to 180 together. So we know this one also is 120 degrees. So regardless of which way we put it, that always is going to be the biggest angle. Either this angle is 120 or this angle is 120. But it looks like A is your correct choice then, because that is answer choice 120, which was the largest of all the options anyways. So had you just picked the biggest number, you would have got the biggest angle. Alright, so this one is 34, and it has a proof for us, but it's a really easy proof because it's just an algebraic one. So it starts off with the equation f4x minus 7 equals 2x plus 3. And then somehow it changes into 2x minus 7 equals 3, and they said it was a subtraction property, and then 2x equals 10, and then x equals 5. So let's take a look. How did I change from here to here? Well, we can see that this start off as 4x minus 7, this start off as 2x plus 3, and all they did was subtract the 2x from both sides. Oh, doesn't want to write that there. There we go. So we subtracted the 2x, that canceled out here, and changed that into 2x. So what happened from step 1 to step 2 is what goes in for the reason. So the same process goes from step 2 to step 3. What happened is just going to be our reason here. Just like down here, between step 3 and step 4, we divided both sides by 2, which is why I wrote the word divide here. So what did I do here? How would I solve 2x minus 7 equals 3? Well, that's easy. We know how to do that. We would just add 7 to both sides and get 2x equals 10. So what we're missing here is addition, which happens to be answer choice A. A for addition. Alright, so on to 35. 35 shows, it's a really, really bad picture, I know, but it shows the triangle PQR. P, Q, and R is drawn with those vertices that it gave me there, but I didn't put those on my picture and I didn't draw the graph, but we'll work through it. This triangle is transformed to make triangle P prime, Q prime, and R prime. That's what that little mark right here, this little mark is prime. Q prime, R prime, and that goes over here. And they show that this here is P prime, and they showed that this here is Q prime. And it says if the transformation is a reflection, then what are the coordinates of point R? Well, a reflection means that wherever we are away from something, it's the exact same away. They both are the same distance away. So if you look at point Q right here. Well, if you count over to your axis, we go 1, 2, 3. It's 3 units away. And if you count over this way, 1, 2, 3. That Q is exactly 3 units away. So if R is just 1 unit away, well, then we know that this R also has to be exactly 1 unit away. So that means that we're going over 1 this way, and it looks like it's down at negative 2. So 1, 2. So the point is 1, negative 2. So R prime is 1, negative 2, which happens to be answer choice A. Alright, it looks like this is the last one. Number 36 shows that rectangle RCTG has two of its vertices, R negative 2, 3 and C negative 2, 1, which I've gone ahead and drawn there. Notice that because it's a rectangle, there's something very important. The x values here have to be the same because wherever it started at the origin, if my origin was right along here, quick dotted line, well then this is negative 2 units away. This better be negative 2 units away, or else it's not going to make this nice straight line that we know rectangles have to have. Same thing here. If I go over here and make this nice straight line and this nice straight line, well, we should expect this to stay at negative 1 and this one to stay at 3. It's not going to jump up and down and get all zigzag. So we know this point should end in 3 and this point should end in negative 1. And very similarly over here, these both were at negative 2. Well, these both should have the exact same x value because we want it to be a nice straight line right there. So if you just quickly take a look, you can see that there's no answer choice that works that has negative 1 and 3 except for C, and that has 5 and 5 here. And we know that's okay. As long as those two are the same, that means it's going to make a nice straight line here. So it looks like answer choice C has to be the only answer. This problem, if you don't know how to do it, if you don't understand that, you could go through and graph each of those points. If you went and graphed A, you would see that you would end up with a rectangle that does something like this. And we know that's not a rectangle. If you went and graphed B, you would see that by the first point you graph, it was just right here. So it's just making a really long line. That's not going to do you any good. And I believe actually the same exact thing would happen with D. If you did the same thing with D, it's just going to make a really long line. So C would be the only one that worked. If you graph C, you would see, oh, that's a rectangle. Oh, that's really easy. So don't make that mistake on the test. If you're unsure, just graph both questions because then you will get it right.